In this section, we're going to be talking about the greatest common factor. Back in elementary school, you learned to find the greatest common factor. I'm going to show you a new way to do that. In order to find the greatest common factor between two numbers, earlier in your educational life, you learned to find it this way. If you had 12 and 42, you would first write out all of your factors for 12, and you learn to do it in order. Remember, I've taught you to do this in pairs. For 42, we would have 1, and there's a lot of them. For 42, 2 and 21, let's see, 3 and 14, and 6 and 7. And you had to be really careful that you didn't leave any of these out. And then you had to find which one is the biggest between 12 and 42. So the biggest one would be 6, and you would make that little loopy circle over those. So I'm going to show you a new way to do this that I think you might find will be easier than this old way. We take our numbers 12 and 42 and we make a ladder, just like when we did prime factorization. And we start finding prime numbers that go into both 12 and 42. Well, 2 is the easiest, so we divide both 12 and 42 by 2, so 6 and 21. Then we find a prime number that goes into both 6 and 21, which would be 3, and 2 and 7. Now, nothing goes into 2 and 7, so we stop there. And our GCF is the number we get when we multiply our numbers on the side. So our GCF is 6. Now, this is very easy, and you can learn to do this very quickly. Another thing I want you to learn is when you do GCF, these numbers don't have to be prime numbers. I could have started with 6 out here. I'll show you what I mean. Let's say we have 180 and 600. Well, I know 10 goes into both of these numbers, so 18 and 60. Okay, so I didn't have to put a prime number out here. Okay, what goes into 18 and 60? 2 would be easy. 9 and 30. What goes into 9 and 30? 3. So 3 and 10. What goes into 3 and 10? Nothing. So I stop. Then I take my numbers over here on the side and multiply them. That would be 6 times 10. So my GCF is 60. Real easy, and you'll get to where you can do this very quickly. All right, let's try another one. 112 and 63. Okay, this is a kind of a hard one. Now, 63 is my smaller number, so let's start with that. Let's think of all the factors of 63. We have 1, 63, 2, no, 2 doesn't go in there, 3 and 21, and 7 and 9. Any more? No, that's it. Now, do any of these numbers go into 112? Let's try. 1, nope, nope. 3, nope, because remember we add our digits. 4 cannot be divided by 3. 21, let's see, 21 into 112. Don't forget, whenever you need to, do a little bit of scratch work. That won't work. What about 7? Will 7 go into 112? 1, 7, 4, 2, yes, 16 times. Okay, so I know that 7 goes into both our 63 and our 112. So I'm going to divide 16, got that up here, and then 7 goes into 63 9 times. Okay, what goes into 16 and 9? Nothing. So we stop, and our GCF is 7. So sometimes it takes a little more work, but I guarantee most of them are going to be real simple. All right, I want to introduce you to a new term, relatively prime. Relatively prime means two numbers that only have the number 1 as their common factor. So if you wrote out all the factors, the only thing that they would have in common is 1. For example, 4 and 9. The factors of 4 are 1, 2, and 4. The factors of 9 are 1, 9, and 3. The only thing they have in common is 1. Can you think of some other numbers that only have 1 as their common factor? 3 and 13, or 6 and 25. Now I want you to notice they don't have to be both prime numbers. Now they can be, like 3 and 11. Those are both prime numbers. But 6 and 25 aren't. 3 and 13 are. 4 and 9 are both composite numbers. Another thing that will help you on these, if you have consecutive numbers like 4 and 5, those are consecutive. They come one right after the other. Those are relatively prime. Or 9 and 10, or 512 and 513. Those will always be consecutively prime. Sorry, I was about to sneeze there. All right, so a new term, relatively prime. Practice these, think about those. It's an important word, and that will help you when we start doing more fractions.